you are welcome to this session, session 2 of Unit 4. In this session, we are going to determine the calcium hydroxide content in a sand or soil. Let's proceed to look at our objective. By the end of this session, you should be able to determine the calcium hydroxide content in a sand or soil using the back titration principle. And we start this with a problem to solve. The calcium hydroxide content of a soil sample would be determined by treating the soil with excess dilute HCl and titrating the excess acid sodium hydroxide. Let's look at the next point, which is very important. Solution D was prepared by treating 1 gram of a soil sample with 100 cubic centimeters of 0.2 molar HCl. Solution E is 0.2 molar sodium hydroxide. I want us to analyze this very point well before we proceed. In the titration process, we expect a reaction between the HCl and sodium hydroxide. And this is the concentration of HCl. But this HCl has first been treated with the sand, and in the sand there is calcium hydroxide, which is basic and will first of all consume some of this 0.2 molar HCl. So we don't expect the whole of this 0.2 to react with this. So the plan is that we are going to find the leftover after the calcium hydroxide has consumed some of the HCl. What was left, we are going to find it. We'll come back and subtract it from this. Then we'll know the concentration of HCl that the soil sample, the calcium hydroxide in the soil sample consumed. Then we will now convert it into moles using this volume, and we can do our mole ratio to find the corresponding moles of the calcium hydroxide and find other things that they have asked us. That's how the whole thing is going to be, and that is almost how every back titration looks like. So there is instruction, and we are to find the amount concentration of D, then the moles of HCl that reacted with the calcium hydroxide in the soil sample, the mass of calcium hydroxide, the percentage of calcium ions in the soil sample. And we are to take the average volume of D to be 30 cubic centimeters. So as usual, we would have to start with the species that we have enough information about. When we look at the sodium hydroxide, we have been given its concentration, the volume is there, and we can find the molar mass. So starting with the sodium hydroxide is the ideal thing to do, and we need to interpret the concentration. The concentration was 0.1 mole per dm cube, and what it means is that 1000 cm cube of the sodium hydroxide contains 0.1 mole of the sodium hydroxide. Out of that, it was 20 cubic centimeters that was used in the titration process. So if the whole of 1000 contains 0.1, then that 20 that was used to react with the acid contains what? We have 25 times 0.2 over 1000. That gives us 0.005 moles. We have converted into moles, so we can write the equation of reaction and look at the agreement between them. And this is our equation. The agreement is that if sodium hydroxide gives 1 cd, HCl will also give 1 cd. In other words, the mole ratio is 1:1. So if we have 0.005 moles of the sodium hydroxide, then it will react with 0.005 moles of the hydrochloric acid. So this is, but remember, it was a certain volume. It was the average volume, the 30 cubic centimeters that was given. That was the volume that reacted with the 20 cubic centimeters of the sodium hydroxide. So this 0.005 is contained in just 30 cubic centimeters. But we need to find the amount concentration in 1000 cubic centimeters or in dm cube. So we come again and interpret. In other words, this 0.005 is per 30 centimeters cubed. So if 30 cubic centimeters HCl contains 0.005. Then 1000 will contain 1000 times 0.005 over 30, and that gives us 0.167 molar or mole per dm cube of the acid. So after the calcium hydroxide has consumed some of the acid, this was what was left. Was left with 0.167 moles per dm cube of the acid, and this is what reacted with the sodium hydroxide. So knowing the excess, what do we do? In other words, this is the number of balls of kinky that you gave to your sister. That's the leftover. So if we want to know what the number that you ate, what do? We go and subtract this from the number that your father gave you. So we started with 0.2 molar of the HCl, and we came to meet, or it was left with 0.167. So if we want to know how much is gone, how much has been consumed, we just find the difference, and that gives us 0.0033 moles per dm cubed. So this is the concentration of the HCl that was consumed by the calcium hydroxide in the soil sample. We were given the volume of the acid that was used, so we have to convert this one into moles. So this one with the volume gives us 0.0033 moles. So this is the number of moles of the acid that was consumed by the calcium hydroxide. Another way we could have done that to get the moles straight away was to go and convert this one also into moles using the volume that was given, and then we'll find the difference. So this that we have here is the moles that was consumed by the calcium hydroxide. Knowing these moles, we can move on. This was the next question, so we know these moles. We can now, through the relation between the acid and the calcium hydroxide, now look for that of the calcium hydroxide. So we proceed with the equation of reaction to show the relation between calcium hydroxide and the hydrochloric acid HCl. So this is our equation, and according to this equation, for every 1 mole of calcium hydroxide, we have 2 moles of the hydrochloric acid reacting, and so moles of the calcium hydroxide will be 1/2 times the moles of the hydrochloric acid. In other words, if 1 is equal to 2, then x here is equal to 0.0033. So you cross multiply, make x the subject, and that will give you the same thing that we have here, and your answer is 0.00165 moles. So this is the moles of the calcium hydroxide that reacted with the hydrochloric acid. Now that we know this mole, we can now proceed to find other things that we were asked to find. It was we were to find the mass, and we know that amount N is equal to mass over molar mass. So we can make mass the subject, and that gives us the equation moles times molar mass, or amount of substance in times the molar mass. And so we come and do a substitution. This is the moles we put here, and then this is the molar mass. This molar mass, we had it from the relative atomic masses of the calcium and the hydroxide, considering this 2 here as well, and that gives us 0.1221 gram. The next task is to find the mass of the calcium ions in the sample. Okay, so out of this calcium hydroxide and molar mass of 74 grams in per mole, 40 of it is calcium ions, or is that of calcium. So if 74 grams of the calcium hydroxide contains 40 grams of the calcium ion, then 0.122 grams of the calcium hydroxide that we have found will contain what of the calcium ions? It will contain 0.1221 times 40 over 74, and that gives us 0.066 grams of the calcium ions. Okay, here we can also say that if 74 is equal to 40, then 0.1221 is equal to x. We cross multiply, make x the subject, and we'll still get the same thing. Now that we have the mass of the calcium ion, we can convert this into percentage. So this is the mass of the calcium ions contained in the soil sample. But remember, in the whole of the sample, it was 1 gram that was used, or that was weighed. So out of this one, 0.066 grams is calcium ions. So if we want to know the percentage, we just have to divide the 0.066 gram by the total mass of the soil sample that was weighed and multiply by 100, and that gives us 6.6%. My good friends, I hope you enjoyed this lesson.